Hello, you lovely people. I hope you're having a good time at the Azure Community Conference. Well, I'm excited to be talking to you about micro frontends, monorepos, and trunk-based development. A sort of a 2-year journey of me and my team looking to build different type of frontends and figuring out what works best. A little bit about me. So my name is Vinci Rufus. I'm a senior director with Publicis Sapient. I've been working with JavaScript frameworks since 2012, and I've had a chance to write a book on Angular way back in 2014, which sort of got outdated pretty soon. I've been spending a lot of time nowadays building applications on React. I love Svelte, and I'm learning Rust. Any more questions on Svelte or Rust? Feel free to reach out to me after the talk. So, like I was saying, I've been working with JavaScript frameworks since 2012, and at that point of time, I used to be a huge proponent of single-page apps. As a matter of fact, my very first talk at a conference was on building a single-page e-commerce application with Magento and Angular. And I used to go about advocating that single-page apps were the next best thing. But over a period of time, I've started to realize that single page apps are not as great as what they used to be or what they really sound. And here are a couple of reasons why I think so. So for worse, if you notice that most of the single page apps that you see, they have an app shell, and the whole idea of a single page app is that they load a lot faster. But when you see about loading a lot faster, what it really means, well, the page does load faster. So you have the header, you have the footer, and you have sort of like the static content loading in. But the actual content that you want to interact with is still loading because there is an API call that's been made from your browser to a server sitting far away, waiting for the JSON response to come back, pass the response, and then show it to you. And you're left with looking at loading screens like this. Does it remind you of those days of Flash long time back? Well, aren't single page apps starting to become like that? The second problem that I have with single page apps is the huge bundle size that you land up having to download on the very first hit. This is an example from one of the popular e-commerce sites. And this is the download that I get when I hit the home page. So you notice that I get about 9.4 MB of download, and out of which only about 5.9 MB is actually being used. So it's close to about 40% of the bundle size that's being downloaded on the browser is not being used at all. And that's a huge waste of bandwidth and effort, and especially if you're on low-end devices. And finally, this is my final argument on why single-page apps aren't really great. So this is a video by Jake Archibald where he recorded this quite some time back. And what he tried to show was on GitHub, a single page app loads a lot slower than a server rendered page. So what he does here in this video is you notice that he clicks on a link, copies it, pastes it in a new tab, and then he compares it to see which of the two pages load faster. So you notice he goes, clicks on the link, opens in a new tab, pastes it here. And you notice that the new page on the right has loaded, while on the left hand side you can still see the progress bar growing up. And that shows you the difference in how fast a server rendered page can load as compared to a client rendered app. So which means over a period of time you realize that single page apps aren't really as fast as they're supposed to be. And this is my pet problem with single page apps. Shipping a single page app feels like you're actually shipping a really huge cargo bundle from one place to the other. Every time you make a small change, in one of the components on one of the pages, but for you to deploy that particular change, you have to bundle the entire application and deploy that. Imagine doing that on a really large e-commerce site. It can be quite unnerving. And plus, you have to keep doing regression testing of your entire app for every click or every deployment that you do. And when you come to think of it, your single page app is sort of like a big monolith sitting on top of microservice architecture. And that sort of breaks your entire philosophy and principles of microservices, doesn't it? So, in my opinion, the way forward is with micro frontends. And one of the reasons why I think micro frontends is the best way forward is because micro frontends work very well with a microservices architecture. So you have vertically sized applications, you have microservices built, you have a micro frontend that consumes those microservices. You can independently deploy those microservices and the respective micro frontend without having to touch the rest of your application. So, what are some of the core principles of micro frontends? For me, the first one is breaking down your application by the domain context. The domain driven design is a very popular concept when it comes to microservices. You sort of follow the same principles when you're working with a micro frontend. The ability to deploy each micro app independently. I think for me, this is the most important principle for micro frontends. If you're not able to deploy a micro frontend independently without having to deploy the entire application, then there is no purpose of doing micro frontends. So this is an important characteristic. The ability to isolate failures. So imagine you have a large application being deployed, something breaks somewhere. Fine, that particular app doesn't load properly or it shows an error message. But can the users navigate through the rest of the application without being impacted? So micro frontend allows you to isolate failures to a certain section. Micro frontends need to be highly observable. I'll probably touch upon this as we move later. And similar to the principles of microservices, you need to have a strong culture of automation and DevOps if you're working with micro frontends, because you're going to have a whole bunch of applications being deployed or micro apps being deployed, and you need to have a much better way of managing them. So, when you talk about micro frontends, I've seen about 3 or 4 different types of micro frontends being deployed. The first one is every component is a micro app. So you see scenarios or architectures where every component is converted into a micro app, and then you have different components or micro apps being stitched together on a page to load up the entire page. That, in my opinion, is a little too extreme version of a front end, micro front end, because one is you're getting too granular and you're not really reaping the benefits of having a micro front end architecture. But the overhead of maintaining that architecture is quite high. The next pattern that you see is where every page is a micro app. So you have the home page, you have the PDLP page, and the PDP page. Each of them are a micro app, each of them are bundled and deployed independently. That works fine. I see a lot of this pattern in the retail commerce space. You have the next version of micro apps where they are essentially a collection of apps in itself. I see this pattern a lot more in the banking and the financial services space. So, say for example, you're building a huge banking app, and as a part of the banking app, you have different micro applications, right? You have an application for managing accounts, savings accounts. You have an application for managing loans. You have a separate application for managing credit cards. And within each of that, you have pages which says view transactions, make a transaction, make a payment, so on and so forth. So each of those micro apps are kind of collectively kept together and they could form a micro front end architecture. So there are multiple patterns of making micro front ends, and I don't think any one of them is right or wrong. And that's also one of the reasons why I kind of advocate that rather than calling it micro front ends, can we move to the notion of calling them as micro apps pattern? The reason is because a micro app can mean anything. It could be an individual component, it could be a page in itself, or it could be an application or a collection of pages. And all of them are very valid micro front end architecture. Now, once you've decided to go with micro front ends, I think the next 2 decisions that you need to make is how are you going to organize your code into your repositories and what kind of a branching strategy that you plan to use. And what I've realized is if you're doing micro frontends, then the most optimal way to manage your code is in monorepos. And if you're doing monorepos, then you don't have much of a choice than to go with trunk-based development. So let's look at the pros and cons of each one of those. We've already talked about the benefits of using micro frontends. So let us talk about some of the challenges that you face when you're working with micro frontends. The first one is routing. Now, because you have each of your micro apps built as separate applications, how do you move from one app to the other? So that's a problem. The next problem is how do you share state? So the state for each micro app can be maintained within itself, but what if you want to share state between the two micro apps? How do you do that? And then independently deploying those micro apps is going to be a problem. And finally is how do you manage your local dev setup? So these are some of the common architectural problems that you face when you're working with micro frontends. And how do you try and address some of those? So as a strategy, I think the best way to solve any micro frontend architecture problem is to sort of abstract away the app level routing and the app level state away from each of those micro apps. So if you look at an architecture like this, what we try and do over here is the routing, the root level routing that happens from one app to the other is sort of abstracted away from the micro app and moved into something like an Nginx or something. And the state that you have is now taken a level lower and kept in a sort of an orchestration layer or a layer like GraphQL. And once you've done that, then each of your micro apps sort of become independent and sort of isolated from each other, which means you can independently build and deploy them. And it also sort of gives you an opportunity to sort of try and use different frameworks for each of those micro apps. Not that we would recommend that, but that works as a great strategy for upgrading. So when you talk about routing, how do you manage that? So a couple of options are always available. So what we recommend is the root level routing is the one that you sort of abstract away from your micro apps. So which means the parent level routes that you have, that is managed in say something like a CMS, or you could use Nginx to manage those app level routing. And then the secondary routing that is there, those are all managed within your respective micro apps. You could use something like a React router or whatever routing tool that comes as a part of your JavaScript framework. Then the next thing is how do you manage state or how do you share state between each of those micro apps? And the answer to that is as much as possible, do not share state between micro apps. If you come to a point where you find the need to share state between each of those micro apps, then you need to go back to the drawing board and see why is that happening. Either you have probably not broken down your micro app in the right way, or there's something going wrong somewhere. So ideally, you should not be sharing state. And if at all, there is a reason where you need to share state on an occasion for once or twice, then you probably want to do something like a PubSub, an event-driven PubSub mechanism, or use something like a GraphQL layer. And then the next thing is about how do you manage your local setup. Now, when you have each of your micro apps built, you usually are probably running them on different ports. So how do you navigate from each of one app to the other? There are two possible solutions. You could use Docker Compose. So each of your micro app gets Dockerized, and then you use something like a Docker Compose to stitch all of them together and make them work. Or you could use something like a proxy server. So Webpack Dev Server comes with its own proxies, and you could hook into that to create routing between one micro app to the other. So that's how you can address some of the challenges that come with setting up micro frontend. Let's now talk about monorepos. A lot of people are scared about monorepos. And I think the reason for that is because the moment you mention monorepo, what they assume is that a monorepo is essentially a single repository for the entire organization, which means all the applications built as a part of the organization, be it web apps or native apps, are all kept and maintained in a single repository. Well, the likes of Google and Facebook can afford to do that, but for teams like us, it can be quite a bit of an over challenge. And the way I would like to think about monorepos is a little different. It's not about keeping all your applications within a single repository, but it's about breaking down a repository into a monorepo. So think of if you had to build this application as a single page app, you would obviously build it as a single repository, isn't it? Now, if you're building that as a micro frontend, what you would do is simply convert that repository into a monorepo, which means it's still a single repository, but now you have got different packages or different micro apps which you can independently build and deploy. And that for me is what a monorepo is. Well, actually, monorepos and multi-repos go way beyond just organization of code. I think they also go quite deep into how teams operate and the culture and the maturity of the teams, and also in terms of how it impacts the CI and CD pipelines. So let's look at a couple of pros and cons, or I would say the differences between a multi-repo and a monorepo. So to start with, the multi-repo gives you maximum flexibility because each app has its own repository and can be independently built and maintained. When it comes to a monorepo, you don't have that flexibility. And as a matter of fact, we actually say that we intentionally restrict that flexibility so that we ensure that all the team members are moving in the same direction. With multi-repos, module upgrades can be easily deferred and delayed. So say for example, there's a new NPM package available for one of the third-party libraries that you're using, or it could also be one of your internal helpers or utilities that you've built, or a component library. So with a multi-repo, you can obviously choose when you want to upgrade it. However, when it comes to a monorepo, you don't have that flexibility because in most common scenarios, your monorepo maintains a single package or JSON file, which means whenever you're upgrading a package, it has a direct impact with all your applications in that monorepo. So that could be a good thing and a bad thing. And that brings down to the next point with regard to if something breaks, who is responsible for breaking or who is responsible for fixing those breaking changes? In a multi-repo, obviously, the team who owns that repository is responsible for fixing those breaking changes, which means there is always a tendency and a way to sort of delay upgrades because you're always scared that something is going to break. And also, there is no pressure on people who are creating these packages to make sure backward compatibility. In case of a monorepo, it's interesting. The responsibility for fixing those breaking changes actually resides on your core team. And why is that? So, in a monorepo, obviously all your shared utilities are all part of the same repository. So, if you're making a breaking change in one of those utilities and you try to push the change, your CI/CD pipeline is not going to let you go ahead and build that application because your applications are going to break, which means your code will never get merged, which means you are now responsible for fixing all your apps to ensure that your pipeline goes green. And hence, what this means is the core teams are usually a lot more careful when they're trying to introduce breaking changes. So that's actually one of the very strong benefits of working with monorepos. The next point is about code ownership. So with multi-repos, code ownership is pretty straightforward. People who are part of team A have access to code of team A, they got write commits, and so on and so forth. When it comes to monorepos, it can be a little interesting because everybody has access to the same repository. So it kind of becomes challenging in terms of how do you give them read and write permissions. and you really need to have a different approach to managing permissions, which we will touch upon later. The other thing to keep in mind is with multi-repos, your build times are usually optimal. So as your application grows larger, you're essentially creating more number of repositories, but the build to build each application kind of remains the same. When it comes to monorepos, there can be a significant increase in your build time as more and more applications are being added. And that's when you need to sort of resort to things like caching. With multi-repos, your CI and CD pipelines are fairly straightforward and simple. They can get quite complex when it comes to monorepos. And finally, with the multi-repo, there is a high tendency for teams to get siloed and diverge very quickly. Now, with the monorepo, and because of point number one, the teams are always sort of cohesive in a way. And the other benefits of a monorepo is every team member has access to the entire code base, which means I can learn from other people's style of writing code. So I can look at what other team members are building and see what components and libraries that they are building and using. And if there is something that I can take advantage of, I can probably use them and share with them. So when you look at the pros and cons of multi-repos and monorepos, this sort of like 50-50, or sometimes it may feel that going with the monorepo does feel a lot more complex. But I would still strongly recommend that you go with monorepos because I think the benefits that you gain over time far outweigh the initial complexity that you have to deal with. And overall, they definitely help improve the maturity of your teams. And when you're working with monorepos, there are basically two common libraries or frameworks that you can choose from. The first one is Lerna, which is one of the earliest package managers for monorepos, and the new kid on the block is NX. So between Lerna and NX, I think NX has a lot more features, and that is something that I would strongly recommend. So some of the new good things about NX is, in my opinion, it's probably one of the most advanced set of tools for monorepos, and it has a whole bunch of generators and schematics that allow you to easily scaffold an Angular app, a React app, or a Node app out of the box with all the bells and whistles built in. You can also easily scaffold out storybooks. So if you have a component library and you want to create a storybook for that, it's fairly easy to do that. And it also comes with built-in support for Cypress. So which means every app that you build, it also creates a corresponding app that allows you to write your end-to-end testing using Cypress. So it sets up everything ready for you to quickly get productive when you're working with monorepos. Getting a little deeper into the folder structure of how NX sets up your applications. So it creates a whole bunch of folders for you, folder files and folders. But you need to be worried about, or you need to care primarily about two broad folders. The first one is your apps folder. And the apps folder is where you have all your micro apps set up. So your accounts micro app, your browse micro app, your cart micro app, they're all part of your apps folder. And that is the one that you sort of build and deploy. You also have something called the libs folder. And the libs are essentially meant for shared libraries, where if you have any common utility that is being used across various micro apps, you'd probably keep them in the libs folder and use it from there. And keeping stuff in your libs folder also negates the need for you to publish out your shared libraries as NPM modules. And that, in my opinion, I think is one of the strongest benefits of using a monorepo. Some of the other benefits of a monorepo, or for example, in this particular case, NX, is that it very easily allows you to identify your dependency graph. So if you are making a change to a certain file or a folder and you want to see what is the impact of that particular change, you could run a simple command called dep graph, and it would tell you what are the hierarchy of changes or the hierarchy of applications that are dependent on a certain file or a micro app. So I think these are some of the really good features that come as a part of NX that make life easier when you're working with microfrontends and monorepos. And coming back to the point of how do you manage permissions with monorepos? So when you're working with multi-repos, we're sort of so used to setting up permissions at a repository level that when it comes to monorepos, we kind of get stuck with that and we don't know how to go about doing that. But I think the answer to managing permissions with monorepos is very different. The whole philosophy with monorepos is about inner source and open source kind of collaboration. So which means everybody in your team should have access to look at all the code that is there. But at the same time, you also want to make sure that people are not sort of wrongly committing changes to files or folders that they don't own. And that is where your code owners file comes into picture. So a code owners file is a very simple file where you create a sort of list of folders and who the corresponding owners are. And what this does is this allows all the team members to look at each other's code, and it also allows you to raise a PR to sort of either fix a bug in somebody else's code or sort of improve somebody else's code. The only restriction over there is that PR can't be merged unless that code owner for that particular folder or that team approves that PR. So I think that is a very nice and a healthy way of collaborating within teams. So as you can see in this example, you have feature team 1 that is responsible for the browse and search micro app, and you have feature team 2 that's sort of responsible for the content micro app. And then you have the core team that is sort of responsible for all the shared modules and libraries as a part of the libs. So this allows you to have individual ownership at a folder level, but still gives you the freedom and the flexibility to look at other code and raise PRs against other people's code. And finally, we talk about trunk-based development, also called as the GitHub flow. When you come to trunk-based development, I think there are a couple of myths around that. And you have some people who say that the trunk-based development is ideally suited for smaller teams and would definitely not work for large teams. And in my experience, what I've realized is if you have larger teams, then you must be going for trunk-based development just to keep the whole branching strategy simple and to reduce the communication overhead that you have different teams. People also have this sort of notion that the master branch or the main branch is sacrosanct, and any code that gets merged into master has to be like 100% clean and production ready and so on. And due to those principles, they're just too scared to merge any PR into master. And I think that's just an unnecessary overhead. You should be fairly comfortable merging your PRs and code into master and ensure that your master is as stable as possible. And people also have this notion that if you're doing trunk-based development, you also have to start implementing code freeze during every deployment. So which means once all your PRs are merged into master and you have cut out a release, no further PRs can be merged until this particular release is taken to production. And I think that's a very old concept. In today's world, when you're doing frequent deployments, you can't afford to have code freezes. So all of these myths about smaller team work suitable only for smaller teams or not worrying about merging code to master or code freezes can all be negated if you sort of follow the right strategies with trunk-based development. And this is what I've realized over time. So when you're doing active development on a trunk-based branching strategy, it's a fairly straightforward process, right? You have a single master branch, all team members are branching off master, creating a feature release or a bug fix, committing the PRs, and they raise against master. And if the PR is approved, they merge it into master and then they continue forward. So that's a very common practice that we follow. I think the change comes in once your code has got deployed to production. So over here, what I've realized is once your code is deployed to production, there is a change in your deployment strategy. So what happens now is you branch off master regularly, you work on your features, you work on your bug fixes, And once that is done and tested, you would ideally release to production from that branch, which means on your feature A branch, you create a tag, you deploy the tag to production, you monitor that in production and see how well it's working. And once it's stable, only then you merge it into master. This has got a couple of advantages. For one, you can have multiple release branches being worked upon in parallel, and you can go to production with 2 to 3 releases on a single day. And this also sort of brings out this whole notion that it's probably okay to break production, but it's not okay to break master. Because imagine you have a very, very large team and everybody's working off master. And if you've broken master, then all your teams are blocked, which is a huge productivity loss for your entire team and also has an impact when you want to start off create hot fixes on production. However, if you're breaking production, it's not as expensive because it's very easy to roll back. And now with things like Kubernetes, where you have a history of all various deployments, it's very, very easy to deploy a broken production with a stable one. And hence, the strategy of deploying from a branch to production and only when it is really stable, merging it into master is something that a lot of teams are now starting to adopt. Once you've kind of finalized on your strategy for your micro frontends and decided whether you're going to use monorepos and trunk-based development, the next step is how do you get them deployed on a Kubernetes cluster? And I think that is an easy part here. So if you look at this particular diagram, you basically have two set of clusters. So at the bottom is you have the federated GraphQL layer. So you have each of your micro apps on the GraphQL side, which is your content services, your product services, your order services, and your account services. All of those pods exposed via a service, which is a GraphQL content service, a GraphQL product service, order service, and account service. And all of these federated via a GraphQL gateway. So which means now there is a single GraphQL endpoint via which I can query and get data for content, product, orders, and so on. So the bottom half are a set of pods and clusters for my GraphQL gateway. And on the top, what you see are the pods for my React micro frontend or the JavaScript micro frontend. And as you can see here, so you have got pods for content, catalog, and checkout, and each of those exposed via a content service or a catalog service and a checkout service. And you have an ingress controller where you have different paths defined. And the paths are defined such that, so if anybody hits the /content route, it is automatically sent to the content service. And if anybody is hitting a /shop route, it is sent to the catalog service. And anybody is hitting a cart route, is sent to the checkout service. So once you have your Kubernetes set up like this, your application is up and running. So any request that's coming in via ingress with the /content, this goes to the content pod. The content pod in turn makes queries to the GraphQL gateway, gets the required data, serves it back, and the user is able to navigate from there onto the shop pod, which does the exact same thing, and so on and so forth. And each of those micro apps can now be deployed via a fairly straightforward Azure DevOps pipeline. So what we've done over here is we have created a different pipeline for each of your micro apps. Now, ideally, had it been Jenkins, so we could use something like build with parameters and just have a single pipeline that we could run. And from a dropdown, I could just select what parameters to which micro app to deploy. But over here, I'll probably create independent pipelines for each of those and have triggers in place that if there's a change happening on the content micro app, then automatically the content app is getting built and deployed. An important thing to keep in mind is the micro frontend premium or the micro front-end tags. Way back in 2015, Martin Fowler wrote a pretty nice blog post on the microservice premium, where he goes on to explain at what point does a monolith become less efficient and when the value of microservices start coming into picture. So kind of taking the same graph as is, because it sort of explains and has an exact same representation of what happens with microservices. So if you look at this particular graph, what it's trying to say is it's basically a graph of complexity versus productivity. And what it says is if your complexity is low, then it makes a lot of benefit to go with the monolith, because the monolith will give you a lot of productivity gains. But as the complexity goes on increasing, then the productivity starts rapidly dropping down, and you get to a point where productivity is really, really low. On the other hand, if you look at micro frontends or microservices, there is always a sort of an upfront cost when you're starting with micro frontends, which means that there is a fair bit of effort that goes in when you're working with micro frontends. But the benefit of that is as the base complexity keeps on increasing, you don't see any significant drop in productivity. And what this goes on to say is that if you're looking to build a small application, then you probably don't need micro frontends. A single page app or a monolith in that example was most suited because that will give you the most productivity. But if you're sort of confident that over a period of time your application is going to grow to a fairly large size and scale, then it probably makes more sense for you to start with a micro frontend architecture. So that's this whole notion of the micro frontend premium or the tax that you need to pay upfront, hoping that you get better returns as the complexity keeps on increasing. And there were a couple of gotchas in our whole experience of working with micro frontends. So a couple of things to keep in mind if you're starting on this journey. For one, the build times on the pipelines can start significantly increasing as more and more micro apps start getting added. And unless you have a very strong caching capability built as a part of a pipeline, your build times can take very long time to build and deploy. The other thing to realize is that initial setup of a micro frontend can get fairly complex. People who are used to using Create React App or standard single page application frameworks, you do an npm install, you do an npm start, and your application is up and running. But if you want to do something with micro frontend, you have to work with monorepos, you have to worry about proxying, you have to worry about how routing is going to work. So that whole initial setup itself can take a bit longer. And finally, is if you're using micro frontends, monorepos, Strung-based development, it does require a fair bit of engineering maturity for your teams to be able to start adopting this and be really productive. If you do not have a mature engineering team, you can start fumbling quite a bit. So all of that is great. I want to leave you with a small thought of what are the benefits that can come once you've done micro frontends. So once you've implemented a micro frontend architecture, you realize that everything is sort of decoupled, is abstracted away, and you can sort of on the fly create dynamic UI. So this is one of the ideas that we've been experimenting with on the lines of computational design, and also in terms of how AI-driven UI can come into picture. So this is a futuristic group. This is not done by us, but just a possibility of what all is possible if you're working with micro frontends. So here you see an example where you can basically create a quick sketch, have an AI tool that reads the sketch out and spit out an HTML or a sort of a template with your various micro apps slotted in. And what this basically means is you can move from wireframe to a production ready code in a matter of minutes. Otherwise, what would usually take you is days and weeks and months in the current process as of now. So I want to leave you with this thought of what the possibilities of micro frontends are. And thank you.